Welcome to the introduction to weather or meteorology. We're going to talk a lot about different aspects of the weather in this next 8 weeks, and you're going to get a real chance through your labs and through me talking and showing you to spend a lot of time learning about weather maps. You may not be that interested in them now, but you will be. So this week we're just going to talk about monitoring the weather and what it is. We'll start pretty simple here. So what are some of the basic characteristics? Well, let's just define what weather is. If you walked outside right now, what would the weather look like to you? And that is really what's interesting about weather is we want to know what the weather is at this moment in time. And then we want to translate to that another time to do a weather forecast. But the actual definition of weather is what's happening right now. And a lot of the times when you want to forecast or whether you want to know what the weather is, you want to know the temperature. You probably want to know how much moisture is in the air, how cloudy it is, or is it going to rain on your head or snow? How strong the winds are, even where the winds are blowing might be something you're interested in. And we're going to talk about each one of those in an individual basis here over the first probably 5 weeks of the course or so. How you can access the weather. There are numerous ways. You can get them on weather radio, all over the place. And one of the interesting things is because we're looking at weather at one time, even though it's 4 a.m. in the Pacific time and 7 a.m. in Eastern time, the observations are plotted on the map as if they are exactly at the same time. So knowing time zones, we can know that, yes, that observation was taken much earlier out in the Pacific Ocean, maybe, but it represents the exact same time. What we do for time zones is we use the universal time or the Greenwich time as our standard. In other words, we look at what we call 0Z, midnight in London, England, literally, and 6 hours later from that, or 12 hours later, and they're what we use as a standard time to plot a weather map. Because weather's constantly changing, we want the weather all at one given moment in time. Here you can see a very quick weather map. We see a high pressure system, low pressure systems. Notice fronts are connected to the low pressure systems. So the bad weather is around the fronts or around the lows. Usually good weather is around the high. And highs generally rotate counter. They always, in the northern hemisphere, rotate clockwise. So that is one of the things. If you're at the center, you're around the high. If you were driving north, for example, from the center of a high, your winds are going to be coming out of the north or northwest. The same thing with a low pressure system. They turn counterclockwise. So, for example, if you were driving away from the center of a low pressure system, your winds are going to be turning more to the east-northeast. Air masses are just large areas of the same type of air. In other words, they all have maybe same characteristics, similar humidity, similar temperatures, and they form over large continents or large bodies of water. And warm fronts tend to bring warmer air in. They're shallower, and we'll get into a reason why later. And cold fronts are steeper, but you can see cold fronts tend to have more thunderstorms with them. Warm fronts can bring thunderstorms, but they also tend to have longer periods of rain. And everything I'm saying here, weather is three-dimensional. So that's why we just showed you that in the three-dimensional picture there, so that you'll get an idea that we're not just looking at weather at the surface of the earth, but we're looking at weather all the way up through the surface. And, for example, if you happen to be a pilot in a plane and you were flying into an airport and a cold front just passed that airport, and say you were coming in from the east, you might be interested in where you're going to cross that cold front because your winds are going to shift. Well, if that cold front just passed that airport, it might be real close to the ground when you're crossing that cold front in the wind shift. However, if the cold front had passed several hours before, much higher up in the atmosphere that cold front might be. So that's the three-dimensional aspect of all this. So I wanted to just show you a weather map. Here is a weather map for today. You can see here cold front along the eastern United States, high pressure over the Midwest. That is an air mass of relatively uniform temperatures, a little cooler than to the east here. Down in the tropics, warmer, more humid down South Florida along the Gulf Coast here. And then there's a pretty strong cold front coming into the west coast of the United States. And let's just take a peek at this on satellite image. And this is just a visual satellite. So suppose you were up on the orbit and just looking down with your eyes, this is what you would see. You can see clouds over parts of Ohio into the mountains in West Virginia. Here is that cold front that we saw along the eastern United States. And guess what? There might even be some thunderstorms trying to form along it. Here is that storm system we saw out on the west coast coming in. Lots of clouds with it. That low has a lot of precip with it. There was a low to the east here. And that's right over this area. So, hope you get something out of this. We can look at satellite in a lot of different ways too. It gives you that three-dimensional feel for the atmosphere. And I'll have some more videos later.